In 1865, Jules Verne released a novel titled From the Earth to the Moon. At a time when steam engines were the height of technology and flight was still a fantasy, Verne dared to imagine something bold: humans travelling to the moon. He told the story of the Baltimore Gun Club, a group of artillery experts who built a giant cannon to launch a manned projectile, essentially a bullet, into space. Their goal? To reach the moon. It sounds wild, but here's what's remarkable. Much of what Verne imagined has actually come true. Though his science wasn't perfect, Verne predicted many key elements of modern spaceflight long before rockets, satellites, or NASA existed. His vision was astonishing, and some of his concepts were eerily accurate. In this video, we'll explore how Verne's 19th century imagination foretold real 20th and 21st century space exploration. We'll break it down into themes like space travel, astronaut safety and launch logistics, and international cooperation. So, let's launch into it. Launching a vehicle to the moon. At its heart, From the Earth to the Moon is about launching a manned object from Earth to our lunar neighbour. In Verne's story, the Baltimore Gun Club plans to build an enormous cannon called the Columbiad to shoot a projectile, basically a giant bullet, toward the moon. Sounds ridiculous by today's standards, right? After all, a cannon can't truly reach space. But in 1865, it was the best approximation of rocketry anyone could imagine. Now here's what's amazing. The idea of sending a metal projectile with people inside to the moon is exactly what happened over 100 years later with NASA's Apollo missions. Verne imagined a metal capsule carrying astronauts, a precisely calculated launch trajectory, a return plan for the crew. Verne even discusses their re-entry, and a launch based on Earth's rotation and orbital mechanics. Verne's capsule, the projectile, was launched from Florida, just like the real Apollo launches from Kennedy Space Center. The similarities are hard to ignore. Of course, Verne's cannon method wouldn't work in real life. The force would instantly kill the passengers, but his concept was closer to real spaceflight than any other writer of his time. What Verne got right was the need for escape velocity, leaving Earth's gravity, launching eastward to use Earth's rotation, NASA does this too, and planning the flight path using math and astronomy. In simple terms, Jules Verne didn't know about rockets, but he figured out that with enough speed and the right math, you could reach the moon. He was right. The crew capsule and human passengers. Verne didn't just imagine reaching the moon, he imagined sending humans to the moon inside a pressurized capsule with oxygen, food, water, and even furniture. Let's compare this to the Apollo command module used in 1969. The Apollo capsule carried 3 astronauts, just like Verne's. It was pressurized so they could breathe, so was Verne's. It had stored food and water. Verne thought of that too. Even the shape was somewhat similar, a metal cone-shaped vessel. Verne also addressed important human concerns. The need for oxygen. He describes chemical methods to refresh the air. Food and water, included in the capsule. Comfort, chairs bolted to the floor, padding and insulation. Though he didn't get everything right, he didn't fully understand zero gravity, for example. Verne anticipated that space travellers would need a closed, life-sustaining environment. What's more, he gave the world the concept of space tourism long before the idea existed. His characters weren't astronauts by trade, they were curious civilians. With today's private space flights by companies like SpaceX, Blue Origin and Virgin Galactic, civilians are now taking trips to space. Verne predicted it over 150 years ago. Launch location and Earth physics. One of the most uncanny predictions Verne made was the launch site of the mission. In the novel, the cannon is built in Tampa, Florida. NASA's Kennedy Space Center, from where the Apollo 11 mission launched in 1969, is located in Cape Canaveral, Florida, just a short distance away. Why Florida? Even though Verne didn't have satellites or modern orbital data, he understood that launching closer to the equator allows a spacecraft to take better advantage of Earth's rotation. It gives a projectile a boost in velocity, making the journey to the moon more efficient. NASA uses the same principle today. Verne also calculated the distance to the moon with impressive accuracy, around 238,000 miles, 384,000 kilometers, which is nearly spot on with what we know today. In simple terms, Verne figured out that to send a vehicle to the moon, you need to launch it fast, in the right direction, and from the right place on Earth. He may have lacked the technology, but he nailed the physics logic. Weightlessness and inertia in space. Though Verne didn't fully grasp the concept of microgravity, he described what we now call weightlessness. As the projectile leaves Earth's influence, the passengers inside begin to float. Verne writes about how the characters float freely, their arms and legs drifting in midair and objects suspended around them. This is precisely what astronauts experience aboard the International Space Station and what we've all seen in zero-gravity training videos. Even more impressively, Verne touches on Newton's first law: an object in motion remains in motion unless acted upon by another force. He explains that once the projectile is launched, it would continue moving toward the moon with no need for propulsion. In a time before Newton's laws were widely understood by the general public, Verne explained inertia and orbital mechanics in plain terms. Sure, he didn't account for the need for course correction engines or orbital insertion, but he understood that space is a vacuum and things move differently there. This shows how imaginative storytelling can help explain real science, even when the full science hasn't been discovered yet. Space travel and scientific planning. Verne's novel isn't just imaginative, it's methodical. He describes detailed mathematical planning, calculated flight paths, and even public debates over funding and mission logistics. Before modern space agencies, Verne portrayed public interest in space travel, government funding decisions, scientific societies planning missions, and debates over cost, ethics, and safety. He was essentially describing what would later become NASA, ESA, and other space agencies. The level of detail in Verne's fictional proposal mirrors how real missions like Apollo 11, the Space Shuttle, or even the James Webb Space Telescope are organised today. And perhaps most importantly, Verne showed that space travel wasn't just fantasy, it required engineering, teamwork, money, and scientific rigour. In today's world of Artemis missions and Mars planning, Verne's depiction of structured collective space exploration is truer than ever. International cooperation in space. Though the Baltimore Gun Club is an American creation, Verne's novel includes characters from France, Britain, and other countries representing an early vision of international cooperation in space. Michael Ardan, a French adventurer, is one of the first to volunteer for the moon mission, symbolising Europe and America working together on scientific achievement. Today, the International Space Station is a real-world embodiment of this idea, built and operated by the United States, NASA, Russia, Roscosmos, the European Space Agency, ESA, Japan, JAXA, and Canada, CSA. This level of global cooperation would have been hard to imagine in Verne's time, but he imagined it anyway. Verne's message is clear: progress belongs to all of humanity, and as we move towards Mars exploration and commercial space stations, this message is more relevant than ever. Re-entry and splashdown. Incredibly, Verne predicted not just launch, but re-entry and splashdown. His projectile returns to Earth and lands in the Pacific Ocean, where it's recovered by a naval ship. This mirrors the Apollo missions, where astronauts splashed down in the ocean and were retrieved by aircraft carriers. He even described the need to slow down the descent, although he didn't use parachutes. the concept of impact-resistant capsules, rescue and recovery protocols. It's amazing how Verne visualized the entire journey from Earth to Moon and back at a time when humans had never even flown in airplanes. He understood that a space trip wasn't just about going somewhere, it was about coming home safely. Conclusion: the legacy of Verne's vision. Jules Verne wasn't a scientist, he was a visionary storyteller. Yet in From the Earth to the Moon, he imagined a manned lunar mission, human life inside a capsule, weightlessness, precision trajectory planning, launch from Florida, ocean splashdown recovery, international space collaboration, and he did it 100 years before the real moon landing. His work inspired generations of scientists, astronauts, and engineers. Wernher von Braun, the rocket scientist behind NASA's Saturn V, cited Verne as an early influence. The Apollo 11 capsule was even named Columbia, echoing Verne's Columbiad. Verne's fiction became a kind of blueprint for reality, a way for society to dream big, then work to make it happen. So, the next time you see a rocket launch or hear about sending humans to Mars, remember, it all started with a cannon, a capsule, and a novelist who dared to aim at the moon.